Hello and Assalamualaikum. We are from Group 4 and the chosen topic for our EIS project is the Japan Air Flight 123. To give a clear view, here is the outline of the video. This video will consist of introduction, discussion of topic, technical failures, ethical failures, recommendations, and last but not least, conclusion.
Japan Airlines Flight 123, also known with the call sign of JAL 123. Japan Airlines is founded on the 1st of August in the year of 1951 with 100 million yen, and it is scheduled for domestic routes. Before the tragic accident of JAL 123, Japan Airlines has transported more than 600 million passengers within 20 years and accumulated about 25,000 hours of flight and 18,800 of cycles. On 12 August 1985, JAL 123 suffered a serious structural decompression after 12 minutes into the flight. Then it flight under minimal control for about 32 minutes before it crashed into Mount Tagamagahara. 15 crews and 509 passengers were involved in the crash, with only 4 survivors.
Hi, I'm Jack. I'll continue with discussion on topic. So, back in June 1978, the JAL Flight 123 was involved in a tail strike accident. The aircraft fuselage and the rear pressure bulkhead was damaged and the repair work was done improperly. After that, the aircraft operated as usual. So, the fatigue cracks in the rear bulkhead was developed slowly due to the improper repair work. So later in 1985, the aircraft could not withstand the pressure changes during the flight and components failed ultimately. The aircraft experienced in-flight decompression due to the pressure bulkhead and cracked. The pressurized system of the aircraft lost its ability to maintain the design pressure schedule. Consequently, a large portion of the tail was ripped off during the flight, losing all the onboard hydraulic system, which was 4 hydraulic lines, and losing its vertical stabilizer to stabilize the flight. Hydraulic pressure in the aircraft decreased rapidly and the flight crew lost the whole aircraft's control. The flight crew was not able to make emergency descent at Haneda Airport. Later, the aircraft experienced yawing and rocking from side to side, which we known as Dutch roll. Later, the flight crew could not win the fight of gaining back the aircraft's control, and the aircraft crashed and exploded after several collisions with trees and ridge of the mountain. Lastly, only 4 out of 524 people in the flight managed to survive with serious injury.
Hi, I am Aifa, and today I'll be sharing on the technical reasons of the accidents. There were 3 technical failures that contributed to the accident, which were improper maintenance of tail strike accident, presence of fatigue cracks, and loss of primary flight controls. Firstly, improper maintenance of tail strike accident. Previously, in 1978, the aircraft was involved in a tail strike accident. It happens when the pilots were pulling the flight controls excessively when landing. And from the accidents, the repair was not done according to the Boeing standard, which is the manufacturer standard. And then, no further inspection or repair was done to correct the improper repair. Next is the presence of fatigue cracks. This is due to the improper maintenance of the tail strike accident, and after years, fatigue cracks will develop at the rear of the fuselage. And the fatigue cracks is where the points where pressure acts, and by time, the strength of the fuselage decreases because of the presence of fatigue cracks. Lastly is the loss of primary flight controls. After years of experiencing pressure difference, the fatigue crack could no longer withstand the pressure difference in air. Hence, the cracks caused the aircraft to experience an in-flight decompression. The decompression caused the aircraft to lose all the primary flight controls, which then leads to the pilots not being able to control the flight. And then the accident took place.
So next is I will present about the ethical failure of Japan Airlines Flight 123. There are 5 ethical failures. The first one is lack of transparency. The airline did not disclose the full extent of the mechanical issues with the aircraft, which may have led to the crash. It violates ethical principle of honesty and accountability. Next one is undertrained crew. the pilots may not have received adequate training to handle the emergency situation. The lack of aircraft manufacturers arguably have a similar obligation to make sure that the pilots responsible for the safe operation of their products are properly informed about all the critical systems. Then, failure to learn from the past mistakes. The airline and the aviation industry as a whole may have failed to learn from the past accidents and incidents, resulting in a failure to implement necessary safety measures. Implemented cost-cutting measure is the one of ethical failures because they have failed to prioritize the safety of passengers and crew over the other concerns, such as profitability and operational efficiency. Last one is neglecting maintenance. The maintenance crew of the aircraft may have neglected to follow the proper maintenance procedures, leading to the failure of the vertical stabilizer. The initiation and propagation of the fatigue cracks are attributable to the improper repairs of the said bulkhead conducted in 1978.
Hello, my name is Faris and now I will be explaining on the recommendations. So, to avoid similar incidents from happening again in the future, there are several recommendations that can be applied. First and foremost, aircraft maintenance programs should be developed consistent with actual aircraft operations. A maintenance program that is developed based on the actual operation of the aircraft is more likely to be effective. This is because it takes into account the specific needs and requirements of the aircraft, and therefore the maintenance tasks included in the program are likely to be relevant and necessary. Secondly, repairs should be accomplished in a manner that preserves the original safety feature of the airplane. The original safety feature of the airplane are designed to protect the passengers and others who are on board. Preserving these safety features through proper repairs ensures that the aircraft remains safe to operate and minimizes the risk of injuries and accidents. Then, system redundancy and isolation should include assessment of both physical and zonal hazards. An assessment of both physical and zonal hazards provides a comprehensive understanding of the potential risk to the critical systems. This can help to identify the potential failure points and vulnerabilities that might otherwise be overlooked. Last but not least, fatigue properties of complex structural elements should be well understood so that in-service maintenance programs are properly designed.
JAL-123 suffered a tail strike, then followed by a Bosch repair, and the fate of JAL-123 was sealed after 7 years. After the unfortunate accident, passengers of Japan Airlines reduced by 33% as the public has lost their trust toward the airlines. In 1986, domestic flight of Japan was decreased by 25% compared to the previous year. All Nippon Airways ANA has become a more preferable option instead of Japan Airlines. New inspection and repair procedures were released after 2 to 3 years of the crash. However, on 25th May of 2002, China Airlines Flight 611 crashed with 225 casualties. The causes of the crash were coincidentally same with JAL-123, beginning with a tail strike, then followed by a Bosch repair, such as metal fatigue and riveting failure. In short, these two accidents were mainly due to ethical failure, and the aviation industry and personnel involved had failed to learn from past mistakes.